Okay. So we've talked about inductive reasoning. Let's talk now about deductive reasoning. Deductive versus inductive reasoning. So deductive reasoning is based on logic and facts. Oh, low battery, fun stuff. And we can get those facts from given statements, even if the given statements aren't proven, which we'll talk about in a second. Inductive reasoning is a process that is used to draw a conclusion based on observed patterns, which we've already done. We've drawn conjectures. So exactly how are deductive and inductive reasoning different? Inductive reasoning is based on patterns, which, however obvious they might be, we haven't actually proven those things. Whereas deductive reasoning, we're talking about like facts entered into evidence. You've heard this phrase on like crime shows. This is what those lawyers are talking about. This is something that we have proven, or this is something that we as a group have accepted as true. We have all as a group said this is true. Givens kind of fall into that last category. And I'm going to let you take a minute. I would strongly recommend making a note of just exactly what a given is. What is going on here? And for whatever reason, this is, my first time using the PowerPoint with the iPad, and my my examples have fallen off, and I'm not sure why that is, but I will figure that out for subsequent videos. So here's what we were looking at. What should have been in our, and that's a mess. So let's just do this. We'll rewrite it. So we remember from inductive reasoning, we did patterns, right? We have 2, 4, -1, 1, -4. What are the next two terms? Well, we have to figure out what the pattern is. Here we're adding 2, right? Plus 2. Here we subtract 5, add 2, subtract 5. So if I add 2, my next number is going to be what? -2. And if I subtract 5 from -2, my next number is going to be -7. So the next two numbers in the series are -2 and -7. And we already know this. This is not news. All right, so what about if we were to use inductive reasoning? What does that look like? Well, that looks a lot like using law of detachment and law of syllogism. So here's a law of detachment. It basically says if P is true, if P, then Q is true. So if we have a true conditional and P is true, then Q is true. It's a little bit confusing the way your book has it written, because what they don't really expressly state is that we are talking actually about two different statements. So we have a true conditional, right? So P and Q in a conditional are true. And then in another statement, in a new statement, if P is true, then its Q is also true. And this is what that looks like. So this is the law of detachment. Sorry about my pigeon handwriting. You've heard of pigeon English? This is pigeon handwriting. Part print, part cursive. So let's say if student, and I think this is the example in your book. If a student, I know I've seen it someplace. I didn't make this one up. If a student gets an A on an exam, actually I think, sorry about that, on the final, then the student passes the course. Okay, so here's a true conditional, right? If a student gets an A on the final, here's my P, then the student passed the course. There's my Q. So we have if P, then Q, and we have a truth value of true, right? So a new statement, I'm going to say Felicia got an A on her final. Using the law of detachment and deductive reasoning, what we're going to say is, well, this matches our P up here, right? We're saying up here, if a student gets an A on the final, that's our P. Felicia got an A on the final, that matches. Therefore, we are going to conclude that she got an A, or she passed the course. Felicia make sense? Clear as mud? Well, we'll do more of this in class. So, law of syllogism then is a little bit different than the law of detachment. With the law of detachment, we're talking about one true conditional. The law of syllogism, we're talking about two true conditionals. Two true conditional statements, where one is the conclusion of one statement is the hypothesis of the next statement. Okay? So let's look at what that looks like. This is the table from your book. So let's just take a look at the example here on the slide. If it is July, then you are on summer vacation. If you are on summer vacation, then you work at a smoothie shop. So you conclude, if it is July, then you work at a smoothie shop. You're basically going from P to R in this case. Notice that we are saying in this case, if P then Q is true, and Q then R is true, P then R is true. We can make that conclusion. So here's an example. If we're given a whole number, if a whole number ends in 0, then it is divisible by 10. Our P in that case is what? If anything that follows the if, right? So a whole number ends in 0. Our Q is, it is divisible by 10. Okay, that's one conditional. New conditional, if a number is divisible by 10, and what's our P there? Our P is a number is divisible by 10. Well, notice that that's our Q over here. So we have our Q, and then our R equals, it is, and my pen is dying too, divisible by 5. So the conclusion is, if a whole number ends in 0, it is divisible by 5. We are combining the P from the first conditional statement with the R from the second conditional statement and getting, if a whole number ends in 0, then it is divisible by 5. And we'll talk more about that kind of stuff as well. But I want you to try this one on your own in your notebook. We'll call it a paddle problem, except it's really a notebook problem. And that will just about do it for us for today. I will see you guys all on tomorrow.